Okay, so today's experiment we're going to do is the Grubbs Metathesis. Before we start, I want to briefly mention the history of this reaction. The Grubbs Metathesis is also known as the alkene metathesis. So basically, it's the exchange reaction between the two alkenes from like A, B plus C, D. Then finally you get AC and BD. And here is the catalytic cycle. So first we start from the ruthenium-based catalyst, and then the oxidative addition to the ruthenium center, and then one alkene molecule leaves and to give the other intermediate, and the other alkene molecule do the oxidation addition again, and then the elimination reduction gives a product. The Grubbs metathesis won the Nobel Prize in 2005, and here is the second generation of this catalyst. And the scheme of the reaction is shown here, and here is the structure of the real catalyst. And the first step will be the leaving of the phosphorus ligand, and then you will have this type of the structure. And this part, it is nitrogen hydrolyzed carbene. It can be abbreviated as NHC. So this is the whole reaction we are going to perform in today's experiment. And the real reaction scheme is shown here. We are going to synthesize a natural product from eugenol. So here is the eugenol, and here is our desired product. You can notice that there is one starting material which is symmetrical, so we don't need to consider about the self-reaction of the starting material itself. And the condition will be the Grubbs catalyst in the petroleum ether, which is a non-polar solvent, and it should react for at least 24 hours at room temperature. And because it is a transitional metallic catalyst, so would be air sensitive. So we are using two methods to avoid that. So first, the catalyst you get will be a dispersion in the parachute wax, and it will give the long time storage for the Grubbs catalyst. And second, we are performing the reaction. You need to use the petroleum ether to fill the reaction well to very full, and it will minimize the contact of the catalyst with the air. And the workup will be the gradient column with 10% methyl terbutyl ether in petroleum ether to the pure methyl terbutyl ether. We are going to run the column with from the low polarity to the highest polarity. So that's all we are going to do for today's lab. Okay, so here we have already added the two reagents in the small vial, and also I add the petroleum ether to the halfway. So now I'm going to add the wax dispersion of Grubbs catalyst very quick to the small vial. Then I will add the petroleum ether till the vial is full. But remember to save the space for the cap. Then we cap it tightly and let it stir at room temperature for at least 24 hours. Then we are going to isolate the product. Okay, so after stirring the reaction for more than 24 hours, we transfer all the stuff in the vial to a round bottom flask, and then we load all the contents with silica, and then we run a big column to purify the product. In general, we use the solvent mixture to purify the product, the mixture of petroleum ether and MTBE. From the lowest polarity to the highest polarity, and we collected 8 fractions. Each fraction contains approximately 75 milliliters of solvent. And then we run the TLC of the 8 fractions. So here we use the iodine staining because all the compounds are sensitive to iodine, and then we can see the 7th fraction and the 8th fraction has a higher polarity, and it shows the 7th fraction and the 8th fraction are pure product. Then we will use the rotoweb to remove all the volatiles in the pure fractions. So after we remove all the solvent in the round bottom flask, we use a few milliliter of DCM to dissolve or to transfer all the products in a small earthenware flask, and then we use a heat plate to gently heat it to boiling, and let the total volume to be approximately 8 to 10 milliliters, and then we let it cool down to the room temperature. Then we further put it in the ice bath, let the product recrystallize in the earthenware flask. So after putting the DCM solution, hot DCM solution in the ice bath, we can see there are white crystals precipitated out. Then we will use a vacuum filtration to collect those crystals. And the crystals is shown here. So then we will collect them and submit the proton NMR and carbon NMR for our product. Then we will also measure the melting point for it.